Hey, hello guys, this is Shubhabroto and welcome back to our channel circuiTician. In the previous video, we end up with the Arduino IDE installation. Today, we will see some Arduino hardware boards and we'll do some coding on Arduino IDE. So don't skip the video, watch till the end. Let's get started. As we said that in this video we will know about Arduino hardware boards. So first I will start with the different type of Arduino boards available in the market and which I have used. So I have used Arduino Pro Mini board, Arduino Nano board, Arduino Uno and Arduino Mega board. So in between these four boards, the Arduino Uno, Nano and Arduino Pro Mini have the same microcontroller, which is Atmega 328P, and the Arduino Mega has ATmega 2560 microcontroller. So if you are a beginner and want to start with Arduino boards, I would recommend to use Arduino Nano. But in most of the blogs and YouTube video, you most probably know they recommend the Arduino Uno board. But why I am recommending the Arduino Nano board? The reason is the Arduino Nano board is compact in size and the chip on the Arduino Nano board is in SMD package. Our SMD package has two more analog pins, which is A6 and A7, but the PDIP package doesn't have the A6 and A7 pin. So you will notice the A6, A7 pin in Arduino Pro Mini and Arduino Nano board, but you will not get these two pins in the Arduino Uno board. So for that reason, I am recommending the Arduino Nano. Besides this, you can plug the Arduino Nano in the breadboard and you can also plug the other sensors in the breadboard, so it will be easier to make connections in between them. And one more advantage you will get, that as the Arduino Nano board is very small, so you can directly program it and pack it in a box to make your final project or final product. The Atmel microcontrollers which are present in the Arduino boards is based on AVR architecture. AVR stands for Advanced Virtual RISC and the RISC spelling is RISC. RISC stands for Reduced Instruction Set Computer. This AVR chips is well known for their lower power consumption, and for that reason this type of chips is used in battery powered devices or battery powered systems. In the AVR chips, we can easily get timer, ADC, UART, I2C, this type of important block. And AVR chips are also expert to handle any type of interrupts, which is very important for a microcontroller device. Now I will discuss about Arduino program structure. There is two parts in the Arduino program. One is void setup and one is void loop. If you found these two words difficult, then I will try to give a simple example. Like if you want to turn on a ceiling fan, so what you will do? You will turn on the ceiling fan switch. So you have to turn on the switch for once, but the ceiling fan will run repeatedly until you turn off the power switch. Okay, so in this case, turning on the switch is the void setup part, where you will write the code which will run once, and spinning the fan throughout whole day until you power off the device. This is the loop part, where you have to write the code which will run rapidly until you power off the Arduino. So it is very easy thing. Now we will write the program. In the previous video I have discussed about digital output. So we will perform the experiment of digital output and we will need some hardware to do that. So we need a Arduino, a LED and a resistor. So first we will make the hardware, then we will write the code into the Arduino IDE, then we'll upload the code to the Arduino and we'll run it. Let's go. So first we will put the LED and the resistor in the breadboard, and we will connect the resistors one end to the anode of the LED. So we are making the connection in series. pin number 3 of the Arduino will connect to the open end of the resistor, and the cathode of the LED will connect to the ground of the Arduino. In the Tinkercad we only have the Arduino Uno, so we are using that, but you can also use Arduino Nano. And we are making the ground pin color to the black, ground wire color to the black, and the pin number 3 wire color to the red for better understanding. After that we will code for this circuit. So we have to open the Arduino IDE, and in the new sketch we have to write the void setup and void loop part. So in the void setup we have to declare the mode of our pin. In our case the pin is pin number 3, and we are performing the experiment of digital output, so our pin mode is output. So declaring the pin mode, we have to write the function pin mode, and in the parenthesis we have to give 2 arguments. The first argument is the pin number, which is 3 in our case, and the second argument is the mode of the pin. In our case it is output. So we are done with the void setup part. After that we have to write the void loop part. In the void loop part, suppose we want to turn on the LED for a second and turn off the LED for a second, which is basically the blink code, but we will write it by our own. We don't use the example code. For turning on the LED we have the function digital write. We have to give 2 arguments in this function. First is 3, which is our pin, and the second argument is the state of the output pin, which can be high or low, or we can say 1 or 0. So you can directly write high, or you can also put 1 here, both will work. After that we have to put a delay of 1 second because we want to turn on the LED for a second. So for that we have to write delay in the parenthesis 1000. 1000 means 1000 millisecond. 1000 millisecond means 1 second. So we have to put the delay unit in millisecond. So for that 1 second we have to write 1000 millisecond. Next again we have to turn off the LED. So for that we have to write digital write, the pin number and the state of the pin. So as we have to turn off the LED, we can write low, or we can directly write digitally 0. So we can turn off the LED now. So we have to put delay again in the last line, because if we do not put delay here, the code will go to the first line suddenly and we will not be able to visualize the off state. So we have to put the delay on the last line also. So we are done with the coding. Now we will copy this code and paste the code in the Tinkercad. So here we have to go to the coding section, and here we will choose the only text option because we are coding in Arduino IDE. So we have to delete the previously written code, and after that we have to paste the code here which we have copied from the Arduino IDE. After that we will click the start simulation button. So simulation is started, and here you can see the LED is blinking at 1 second interval. So this is our first coding for blinking the LED at 1 second interval, where the pin number is 3.
Now let's talk about Arduino data types. There is no specific data types assigned to Arduino framework. The data types in C and C++ is the data types in Arduino also. So as you can see here, Boolean, byte, character, unsigned character, these are the data types in Arduino. We are going to use all the data types in the future programs and exercise. So you can screenshot this table where you can get all the data types and their sizes and what are the examples of the data types you can see here. Now in today's example we are going to use the int data type. Not only int, with int we are going to use const keyword, const int, and then the variable name pin. Pin is the variable name. Const means whatever value you are storing in the pin variable, you cannot change in the middle. If you take int pin, you can change the value of the pin anytime in the program, but you cannot change const int variable, which is the pin. You cannot change in the middle of the program. Why we are doing this? Because we are taking a pin number of the Arduino in this variable. Const int pin. Let's suppose I am taking the pin number 5, and this pin I am using it for a specific task. Now you don't want your pin to be changed in the middle of the program. In that way your application will be broken. So that's why whenever we declare any pin numbers in Arduino programming, which is a hardware pin, we always take const int. You will see in the example coming after this. So this is all about the Arduino data types.
As we have learned about data types, so we will use that in our code. We are using here a data type called constant integer, and we have to write here const int. You can take any name, like here I am taking the name as LED pin, and in this code our LED pin or our output pin is pin number 3, so I am writing const int LED pin equals to 3. After that, where I have written the pin number 3, I have to change with LED pin. So we have to change in 3 place. Okay. So what is the advantage of using this variable or this data type? So if you want to change your pin number, suppose from 3 to 5, you have to change in one place only. But if you are not using a variable, then you have to change the pin number through whole the code. Suppose in this code, if we have to change the pin number without using this variable, you have to change the pin number in 3 places, in the setup once and the loop 2 times. So it will be more easier to change the pin number by using a variable. So now we will paste the code with variable, and here we are keeping the pin number 3 as we have connected the LED in the pin number 3, and start the simulation. So here you can also see the code is also working like previous. So here we only have a change that we are using a variable, and the variable data type is constant integer, because throughout the code our pin number will be same. So that is it for today's video. And if you haven't watched the first part of this embedded system series, then go and watch. And if you want to more videos about this series, then subscribe to my channel and click the bell icon. And I hope you enjoyed this video and learned something new. If so, then make sure you hit the like button and share this video with your friends and technical community. And if you want to support my effort, then buy me a coffee. A link is given in the description. And the most important thing, be creative.